So, welcome to the PEcAn meeting on modeling cyber infrastructure. Really glad you could all make it. Thankfully, we seem to have gotten good weather. We had 40 degrees and rain for a week solid. That was good to get hoped for in Boston in May. I basically just wanted to start off by giving a little bit of time for introductions, because I know many of you know each other, but not everyone. So you can just, hey Paul, take a minute to kind of go around and introduce who you are and a little bit, maybe either what modeling team or project you kind of represent. Hopefully I'll have a chance to chat with each other a good bit over the next 2.5 days. And I'll kind of dive into the big picture of what we hope to achieve there. So I guess we can start off with Tris, because he happens to be in front of me and embarrasses easily.
Thanks, Mike. Tristan Quaid, University of Reading, and UK National Centre for Further Observation. I'm here representing Jules mainly. I'm part of Jules' science committee and part of the strategy team that works on future directions. Oh, and I should say, for those of you who don't know, Jules is the land surface model of the UK Met Office and sits underneath the Happy Centre climate model.
I'm Martin Nicol from here from Macquarie University. I guess I'm representing the Australian models. So G'day and Mike, well, all of them. I'm responsible for all Australian models.
Forrest Hoffman at Oak Ridge National Laboratory. Do some work on models in PEcAn, but my primary interests and efforts are in Highland, which is a land model benchmarking.
I'm Nell Campbell. I'm currently transitioning from did my PhD and postdoc with Colorado State University, mainly working on the DayCent model and tropical bioenergy systems, and now am headed towards the University of New Hampshire to work with the NEC. So I'm kind of across both of those.
I'm James Simpkins. I'm with the University of Wisconsin-Madison, and I'm a PEcAn team member, first year grad student.
I'm Encore Desai, according to this. I'm also at Wisconsin, and I'm a meteorologist according to my department affiliation, and I run flux towers. I like scaling surface atmosphere fluxes, and I'm a co-PI on PEcAn, mostly because I'm really good at breaking it.
I'm Paul Moorcroft from Harvard University, work on the N2 model.
Sean Servant from Brookhaven National Lab, PEcAn team member, and also working on getting PEcAn involved in NG projects.
I'm Betsy Cowdery. I'm a graduate student in Mike's lab, working on PEcAn. Tomorrow I'll be talking about some of the stuff we've been doing with benchmarking, building a module for PEcAn to do that.
Bill Barton, Colorado State University, DayCent, Century, PhotoCent models.
Don't get started. Trying to working with Sean and for the National Lab on PEcAn and radiation stuff.
Josh Mantooth. I'm a grad student in Mike's lab and working on vegetation standards in PEcAn, and see a little bit about that.
My name is Kevin Schaefer. I'm at the National Snow and Ice Data Center at the University of Colorado, and I work with the CIPCAS model.
My name is Miriam Johnston. I'm a second-year grad student in Poli Sci, so I also work with education.
I'm Matthew Duvenek. I'm a postdoc at Harvard Forest, and I'm working with the Landis model, and grew up in New England and have never been to a professional sports game. I'm excited about that.
I'm Ann Reho. I'm a student at the University of Notre Dame with Jason McLaughlin on the PEcAn project, but I've been here at BU working with Mike on adding linkages to PEcAn and doing state data simulation and generalizing the workflow.
I'm Alexei Shiklemanov. I'm a second-year PhD student with Mike, also on the PEcAn team, and I work on getting PEcAn to play nice with remote sensing data.
Hi, I'm Islam Park. I'm a postdoc in Mike's group as well, and I'm also a PEcAn member. And I'm working on perimeter data assimilation mainly, and we will have a talk on that on Wednesday morning.
Hi, I'm Colin Averill. I'm a postdoc with Mike. I don't work on PEcAN. I mostly study mycorrhizal types, where they are on Earth, and how they affect soil, carbon, and nitrogen cycling.
I'm Josh Fisher. I'm in NASA's Jet Propulsion Laboratory. I develop CLM and Joules and a couple other models, and I run multiple models and at JPL, part of something we call the model farm, and do a lot of remote sensing as well, and testing and part of model intercomparison projects like MISTI, MIP, and Trendy.
My name is Kevin Wilcox. I'm working with Ichi Liu at University of Oklahoma. I'm doing data assimilation using data from like a grassland drought experiment across the U.S. Great Plains, and trying to scale parameters up to, from local scales to large scales.
I'm Kathy Haynes. I'm from Colorado State University, and I work on the Simple Biosphere model, SIP version 4.
Thanks. I never introduced myself, but most of you know that I'm lead of the PEcAN project, and I hosted my lab as well. Couple orders of practical business before we dive in. For those trying to get on the Wi-Fi, there's you choose the BU guest from the selection of the Wi-Fi options, and then you have to kind of give your life away in terms of name and email and cell phone, and it will either email you or text you a password or log in a access code that you then enter in. You should be able to use that code the whole week, I believe. At one point it renewed every 24 hours, but now I think it's like every semester or something like that.
So what to do without your phone number?
Probably the easiest way is to put in the phone number of someone sitting near you whose name this number does recognize. Other practical orders of business. Men's room is like right down the hall there on the right. You can't miss it. And the women's room is mirror image down one floor. Break room is kind of just around the corner here, and next door on the right, just on the other side of that wall. Where there's some coffee up here. There's also soda and tea and snacks over there, and we'll take a break kind of mid-afternoon. But if anyone wants to grab caffeine of any sort at any point, that's obviously encouraged. And the game. Is there anyone? I just want to get ahead, make sure that we know who is or is not planning on coming, because we kind of did an opt-in thing, but I wasn't sure that everyone knew that they had tickets. We actually do have one extra now, unless someone thought they were going, but they weren't going, and you might have more than one extra.
We can sort that over break maybe, because I have a master list.
I guess what I wanted to kind of sort it out now, because if we have an extra ticket, we can let the grad students in BU know, in the department know that there's an extra ticket.
I have a conference call at 7, so I won't be using it. So
I think you were already on the list of having a conflict. And Tony, you weren't making.
No, I'm not there.
Josh, were you gonna?
I think I opted in.
What?
Yeah, he's in.
I think, yeah.
Okay. So I guess Josh, Tony, we have an extra. So we still have one extra.
We have one extra.
Oh, actually, Paul or Miriam, did either of you want to go to the game tonight?
I wasn't planning on it.
Okay. You're welcome to come if you want, Paul.
No, I'm going myself.
Okay, cool. So we have one extra. Okay. Any other general questions? Oh. You guys want to introduce yourself? We just finished introductions and basic logistics like Wi-Fi and stuff. You want to?
How long are the introductions?
So basically, people said who they were and where they're from, and what project they represent.
Okay. David LeBauer from the University of Illinois. I was a postdoc with Mike when we started the PEcAN project, and still working on its some other projects.
Yeah. Rob Cooper, University of Illinois, NCSA, National Center for Supercomputing Applications. Worked with Mike and David on getting PEcAn and sort of the computer science behind the scenes.
Yeah, Rob's been the senior scientific programmer on the project since early on. So if anything works, it's probably his fault. Despite the attempts of all the ecologists to undermine all the code. Cool. So I wanted to kind of give kind of a general overview talk of kind of what the big what the objectives of the meeting were, and give a quick overview of kind of the state of the science for where the PEcAn team is right now. And then I guess we'll say a little bit about the lightning slide format. If you haven't gotten us lightning slides yet, as long as it's not for this afternoon session, you can continue to drop those in the Google Drive, and we'll do our best to get them in. We're trying to get individual slides that can stand alone in one or more of the themes. So if you sent them in, we've already kind of divvied them up. And Sean and I were at a workshop 2 years ago where Alistair Rogers tried this out, and I think both of us thought it was a real good model because it allows everyone to kind of provide a little bit of more detailed information about what they're doing than just general discussion would, but it also keeps it rolling more than sitting here and through everyone giving a half-hour talk, which would put everyone to sleep. And the unanticipated thing that keeps everyone awake as well is that we don't tell you when your slide's coming up, so you have to pay attention because you could be up next. This actually works to great effect to make you pay attention. Unless you haven't submitted any slides, in which case you just go, Okay. So, why a meeting on modeling cyber infrastructure? Why are we stopping to think about cyber infrastructure instead of just proceeding on with, the more common task of trying to improve models or fit models to data? So I'll start pretty much every talk with a slide like this that basically says, because we're facing a lot of challenges, as a community, we're a long way from the accuracy and precision that we want in anticipating global change. And some of the key challenges we face, a lot of you have been involved with various MIP activities. I know many of you from various MIP activities. And we know that these multi-model validation activities, where you take multiple models in a data set and try to figure out what's going on in the models, can take years of effort for a single MIP. So when we did the NACP MIP, we used the Meriflux towers, and it took us 7 years from start to finish. When we did the face MIP, the face MIP stuff is still ongoing, maybe 8 or 9 years in, and just getting through the 2 of the sites took us about 6 years. And so these activities take a lot of work, and they're only scratching the surface on the data that's available to the community. There's a huge volume of data out there that we're not really making efficient use of as quickly as we could. Other thing I would point out is I would kind of say it's safe to say that the modeling we do, largely in national labs or at R1 universities, is largely a cottage industry. And what I mean there is we've built models that don't have interchangeable parts. And so all of us, most of the models use different inputs, they produce different outputs, and since they have different inputs and outputs that have different formats, we don't have standardized tools, we don't have standardized workflows. There's a lot of reinventing of the wheel. And because of that, it's actually remarkably hard to share work done by one team with another team, and it's remarkably hard to replicate the science that we do. You would think, that unlike field work, which is a major pain in the ass to replicate, that running a model should be something that's very easy to replicate when something is published. But in practice, if any of you have tried to take someone else's model for something that's published and get the same result that they did, it's an enormous amount of work, even if you're on the same team. Even if you're trying to replicate your own work can sometimes be an enormous amount of work. Difficulty. And another challenge that I really think is facing us is that us as the modeling community, the way I view myself as a modeler, is kind of as someone who's a generalist, someone who's had to learn a little bit about a wide range of what's going on in ecosystem ecology, biogeochemistry, biophysics, and atmospheric processes and remote sensing. Like, I know enough to be dangerous about a lot of things, but there's very few things that I am actually an expert on. Most of what I'm an expert on dates back to grad school, so I'm rapidly no longer becoming an expert on the things that I used to be really good at, which was demography back in the day. So the people who really know the processes best and really are the ones collecting the data often find it challenging to work with our community because we've made tools that are not always accessible to a non-modeler. There's definitely a learning curve to get up in using these tools. And even the few of them that have kind of dove in and tried to help us often can help one modeling team with one process. How do we share that information across the community more efficiently so that someone who wants to help us as a whole can do that? I'm sure we've all read too many proposals or papers that have a final paragraph that says, and this cool thing I'm doing should inform Earth system models. Yeah. Okay, but I want to take it to the next step and so they can actually do something about that. So how do we get there? So the argument I'm going to make why we should stop and thinking about cyber infrastructure, because I really believe that cyber infrastructure tools can allow us to spend more time doing science and less time doing redundant activities of basic data processing, basic development, basic tool development, basic replication, time lost on inability to reproduce results. I also think that the modern web environment provides a massive ability to improve collaboration so that we can accelerate this feedback between doing measurements and modeling and improving models to be faster than the publication cycle. We don't want work that's done that improves something. The rest of us shouldn't have to wait for that to then get published and then spend 2 years trying to repeat that in your own model. I've spent time thinking about, for example, the face MIP. I think was one of the most successful MIPs that I've participated in, and that was about a dozen models. If you weren't on that original team, it would take you a lot of time to take what the data sets that were used in those analyses and replicate that work that team did in your own model. And you're not going to get any funding for it because 12 modeling teams have already published that. Try writing a proposal that says, I just want to replicate what those guys already did because it was useful. But it's still useful. We still want to be able to replicate. I mean, all of us would want to be able to use some of these really high-profile, expensive global change experiments as calibration and validation. But how do you do that? It should be something much simpler, much more easy to take what was done by one team and replicate it. In general, hoping to make the science we do more open, more repeatable, and more accessible to a larger community. I really think that's going to help. We need as many hands on board as we can. If we've got more problems, then we've got money or time to deal with them. Okay, so fundamentally on the PEcAn team, why we're doing this, why we're stepping back from our own kind of hypothesis testing research agenda to kind of develop tools, is we think that this is actually the way to accelerate research. Just time invested up front on these sorts of tools should pay dividends on the back end. So our goal is to accelerate research by making community tools. So fundamentally, the goal of our team is to help all of you. And sometimes that's, I want to make that clear. Yes, every grad student and postdoc on my team has their own research project they need to get done. But as a group, what we want to do is provide tools to help the community move forward. We want our collective science to get better. So some people have asked me, about adding PEcAn to my model to PEcAN, are you going to go off and do some new analysis with my model and scoop me? It's like, that's not what we're trying to do. We're trying to make it, we don't want to make it easier for us to run your model. We want to make it easier for you to run your model and do the science that you want to do. Because I think doing that is how we move all of us forward. Okay, so that's kind of the big picture of what we're thinking about as a team. The specific goals of this workshop are kind of fall into two camps. One half that are bigger picture, thinking about how to advance the community as a whole. So I'd like to make sure we spend time thinking about what are the informatic analysis and cyber infrastructure bottlenecks in our current workflow. So in the work that we do today, where are the bottlenecks? So, in my lab early on, it was often, I could get someone trained on how to actually run the ed model in one sitting, and then they'd go off for months trying to process all the input data they needed to run ed at their site. And the bottleneck was processing all of that input data. So for me, that was a key bottleneck, and I really want to know across the community, what are your bottlenecks? Where are you doing something by hand that you're like, man, this should have been automated years ago? Where are your students struggling when they start a new project? Where are they doing things that aren't science? I mean, fundamentally, we invest time in cyber infrastructure so that we can spend more time doing science and less time monkeying. Data monkeying is not science. Okay, second, we've got a lot of different groups here that have workflows. They have patterns of how you guys do your work. I would really like to see what are the redundancies in how we do work. Where are the things that we could work collaboratively on, and where are the opportunities for interoperability? Where are there tools that your group might be using that everyone could potentially use? Where are there methods that are exchangeable? Where can we think about better collaborations on these sort of tool developments so that we don't spend time reinventing the wheel? I mean, I'll get to this in a bit, but just one of the things that kind of drove this home to me was thinking about the work we've done to try to automate getting metadata in. It's one of the things that all of you need, all of us need. And so if we have, M models in N different types of metadata, if we try to solve this independently, we have to write N times N different scripts to process that metadata. But if we use a common format, we can bring each of these N metadatas to one standard, and then fork that out in each of the M models, and then we have to write N plus M scripts. Clearly much more scalable way of solving the problem. Clearly, most of the work that is done this way when we try to solve the problems independently is redundant. Work we didn't have to do. Furthermore, when we bring things to a standard, a lot of the things we have to do on that data, such as gap filling and downscaling and any sort of processing, only has to be done once. We only need one solution to that. So these are examples where I think we really could, as a community, work much faster if we were able to identify where there's redundancies. And then kind of to leave from here, kind of with a roadmap of how, as a community, we might be able to improve the cyber infrastructure that surrounds how we model. So I'm trying to think, kind of the concrete goal, deliverable, what I'm hoping for is to come out of here with a workshop report and possibly even a paper that kind of identifies where do we want to be in 5 to 10 years and how do we get there. So it's thinking about more than just where are we now, but if we had access to all the cool technology being developed by computer scientists, what could we do? Like, open vision a bit bigger. Where could we be, and how do we get there? So this is kind of general community goals. So this meeting specifically comes at near the end of the first year of PEcAN's renewal grant. So the core of PEcAN is funded, it's been funded by NSF Bioinformatics. We're 1 year into our second grant. And we are very much in the second grant focused, it's called a, what is it called, development grant? It's basically about hardening the tools, right? So that they're supposed to, in this period, go from kind of beta research grade tools to tools that are actually used by the community. So we want to make sure the community gets some training in those tools. We want to present our development plan and get feedback on that. So we have an idea for what we want to do over the next 3 years, but if you all say, man, I really need something to do X before your system's useful to us, we want to know that. And if we have some pie in the sky idea that we think is brilliant, but you're all like, guys, we really don't need that, we can bring that down in priority. So this is to help us set our priorities as we try to develop these tools to help you, and then to identify what are the bottlenecks, so what are the things keeping the community from using these tools, and kind of getting feedback on our plan so that over the next 3 years of funding, we can focus on, prioritize the things that need to get done to make these tools most useful to everyone. Okay, and of these 6, this is the one that I think is the most important, the thing that I really want to make sure we walk away from, is this roadmap for improvement. Okay, so basically covered this already. Key deliverables like this paper identifying our bottlenecks, opportunities, and roadmap, and then update. That's our current work plan as it cut and paste out of the grant. We want to know how to adjust our priorities and rejig things to maximize usefulness. Okay. So what I want to do next is to kind of talk a little bit about it'll be 6 or 7 major thematic themes that we identified as a team. And this is just useless. I can get in there. So we as a group kind of tried to divide the cyber infrastructure needs of the community as a whole into a few themes, and I just want to briefly touch on what those were and what the state of the science is for PEcAN. I'm going to structure this around this workflow here. It's my conception of how we bring models and data together in order to make predictions. So first is kind of what I'll call the cyber infrastructure foundations, the basic computational building blocks that enable the other parts of the work. So that would be data standards, tools for communication, database sort of stuff. Data ingest, how we get data in, so the processing of data for drivers, data constrained parameters, data constrained straits, so all the kind of ingest of data into the system. For me, this has always been one of the biggest bottlenecks. And down here, tools for analysis. We think about tools for things like sensitivity and uncertainty analysis, tools for uncertainty propagation, tools for benchmarking, validation, model assessment, things that ultimately feed back. So the first of these kind of feedback to inform what type of data we should be collecting. Others feedback to identifying what are the correct or better model structures and hopefully improve theory, test hypotheses. In the data, this is tomorrow morning, tomorrow afternoon, and then tools for calibration and for data assimilation are another key component. And then finally, in the last part, how we take these sorts of tools and extend them to make sure they work in a multi-model framework. And it's one thing to think about, what are the tools to process, to do benchmarking, and another way would be how do you extend that to make sure it works across a community of models. And what special questions and opportunities and challenges present themselves when you're working with multiple models simultaneously. The basic format of the meeting is going to follow a common repeating pattern over a number of blocks where we're going to have folks from the PEcAn team kind of give you a bit of background on the current state of our system and our plan for where we're going. We're going to, in a number of these, we'll have either live demos of how things work or some hands-on activities, such as this evening, actually getting your hands on this. And then, like I said, we're going to have this presentation of lightning slides, quick slides, letting everyone else give their input on kind of where they see the science and where their challenges are. And then either in large group or breakout, having group discussions on those to kind of really hone down on for each of these themes where are the challenges and opportunities. Okay, so what is PEcAn? So I struggled for a while to figure out how to explain to people who don't know what PEcAn is, what it actually is and what it's trying to do. And the best analogy that I've come up with so far is kind of to compare it to how GIS works and to think about where the field of geography would be today if no one had invented GIS. And so I've pilfered the next 3 slides directly from Esri. Yeah, because they make pretty slides. I mean, that's what they do. So GIS is used broadly to address many challenges. And I think a number of the things that we do, we work with models that are in many ways very general. They're designed to solve many problems. They're not one-hit wonders. Some of them, Bill, you've been working on various forms of Sentry since many of us were in diapers. So, these are long-term investments in tools that have, they're used not just to make carbon cycle projections and climate change, but we use them for, inform management, to inform policy, to, as research tools in many ways. And like GIS, what PEcAn is trying to do is provide tools, methods, and workflows to support working with models the same way that GIS is trying to support tools and workflows to work with geographic information. So things like data ingest, storage, analysis, and visualization are common things that we're trying to do as well. Could you imagine if no one had invented GIS, then you would still have the scores of different geographic information formats that are out there, and you'd have to write like your own custom script to like bring it in, and then you'd have to write your own custom script to like compare 2 data sets. And that's the sort of thing that I think we as a community are doing right now. We're doing a plethora of one-off analyses because we've not kind of stopped to think about how do we develop some more general purpose tools to support the things that we're trying to do. Because we've built general purpose models largely. And then we spent a lot of time thinking about, how do we do this in this kind of Web 2.0 era? So when we actually originally built PEcAn, the first version, it was kind of envisioned as kind of a thing that lived on your desktop or on your server. And it was trying to make a lot of these analyses more accessible and more routine. But how can we, again, take this into a more interconnected framework where we might have, where PEcAn 2 is a distributed collaborative system where we can do work that's more interconnected and interoperable, where we can exchange information as a community more readily. So the core of PEcAn is the model. So what we've tried to do is provide a standard wrapper around that model that says the larger system is going to provide you information about PFTs and drivers and locations and stuff like that in one standard format. You then need to figure out how to convert that to what your model uses, and then on the other side, convert what comes out of your model into one standard format. And so from perspective of this modeling application programming interface, everything that goes in looks the same, and everything that comes out looks the same, regardless of which model is plugged into the system. So it's, even though each model underneath the hood is still unique, we have a common building block to build other tools around that doesn't know about the differences between the models, except in some abstract way. I mean, it acknowledges that we all have different parameters, but I mean, I think the commonalities in what we need overweigh the differences. You know, different models might need slightly different net drivers, slightly different formats, but you know, we all need metadata. You know, we all need data about soils, and we all need data about what the current vegetation is on the landscape, the land cover, and stuff like that. Around that basic building block, we've built a GIS database, PostGIS database that tracks all the inputs and outputs going in, that provides this what's called provenance tree to data, this ability to keep track of what goes in and what goes out and all the processing that you do. So you have a full database that can look up every run you've ever done and everything that went into it and everything that came out of that. So you no longer have to go, which version was the one that I actually wanted, and go hunt through your hard drive and figure out, or worse, your server, to figure out what was the actual production run. On that common core of tools, we built a web interface to try to make this more accessible, and then developed a stream of modules that are trying to each perform, you know, a unique analysis or unique visualization or unique feature on top of this common core. So it's useful tools for execution, analysis, visualization. And we really are moving towards thinking about this as a networked tool. So these are the 4 nodes of the core PEcAn team right now: Illinois, Wisconsin, Brookhaven, and here at BU. And the system is now actually live networked. So this isn't the live view, this is a snapshot from a couple days ago. What green lines mean everyone's talking to everyone else successfully. I have lots of images that show very ugly shades of color that shows when the network breaks down. But what happens is literally that information that's sitting in that PostGIS database is being shared continually between the different nodes in the network. So if Sean does a run on his server, the fact that he did that run, where he did it, with what model, using what inputs, is archived. Right now I can't get his outputs as part of the development plan. Again, it would only be if he flags it as something I can get. But you know, we can start thinking about how we can share information and work as a team and work more collaboratively. Okay, so quickly try to go through for each of those kind of core areas I identified in the larger workflow, kind of where PEcAN is. And this is the 10,000-foot view, and various members of the team will give a more detailed view of each of these over the next few days. I just want to give folks a basic introduction to where we are and what we're thinking about. So we have this idea of a model API. Right now that supports both local execution and remote execution, so this can automatically connect to, so I can run an API on a model that's running on a remote server, and I can use this API to run models that have queuing systems. And it does both combinations, like in a local queue or a remote queue. So this actually allows us to provide support for most HPC, high-performance computing environments. And if we encounter one that it doesn't work with, that's Rob's problem to solve. He's good at this stuff. He works at the Supercomputing Center. They invented the internet. Well, you didn't invent the internet, but you guys did invent the web browser and Telnet. Yeah. And now they're working on PEcAN. You see how far they've sunk since they invented the internet? They're sunk to try and help us. Other core foundations is a few of the standards we use. So the output standard we use for all models is a netcdf file format using the the variable names and units that were the standard for the MIST unit project, which is virtually identical to what was used in the NICP intersynthesis and the PEcAn NIP as well. It's going to be an evolving standard, so as we're in the process of adding more variables that will go beyond the MIST unit core. But that's what we started from. For MET, we have a net CDF-CF standard, so anything in that format, that's the format we convert everything to. That's what we fork it out to the models at the end. And then we have this post-JS database for provenance and sync. Oh, the other thing I forgot to mention up here that is a key part is we've designed this API so that it wraps around each model. So we don't require any changes to the internal model itself to work with PEcAn. We're only working with the inputs and the outputs. So we learned from experience that if you have to have some other thing that's part of the model for it to couple to a system, it's quite likely that that code is going to get out of date. It's going to not stay in sync with the main line. It won't be distributed across all the users of it within a community. And so we thought that it was safer and quicker to provide this external wrapping. That does come at a cost of I/O. So this is slower than some systems that provided direct kind of internal connection to the models. That's just the design that we've made at this choice we made at this point. Because our emphasis was trying to make it as easy for people to get connected as possible. Another core foundation is that we're developing everything we can open source, so development is happening real time on our GitHub account. There's no private account. That's the code. And we also released PEcAN as a virtual machine. So that means that because it's not just code, but it's code coupled to a GIS database and to a web interface, we could release it as a completely operational system as a virtual machine. It's just much easier than getting it all installed. And we're talking about also supporting it through Docker as well. So that's kind of what modeling for PEcAN looks like, just through the web interface. Development in this area, this is largely Rob's focus for the next few years. First is we have this core network of databases. We want to make it easier for folks just running PEcAN on their laptop to push what they've been doing into this larger network. The analogy here is kind of to a pull request like would happen in GitHub. You say, I've done this stuff, I want to contribute it to the community. On the other side, make it easier to get things out of the PEcAN database. So that's going to be both through a REST API and support for threads servers to make it say, okay, if someone else has done runs and they've flagged those runs as accessible to the public, that people should be able to pull not just the fact that I did that run, but the actual outputs more easily. Again, this is going to support privacy flagging, such that you can flag the work you're doing as completely private or public or restricted to at various levels of different groups, so that you can do work within PEcAN without fear of someone else just grabbing it. But when you're done, you can just change the flags and make it open and shareable. And then the other key part is improving data ingest, particularly from some of the more common repositories out there. So we want PEcAN. So right now, it takes a little bit of work to tell PEcAN about data sets. We want to make it much easier for it to just say, if I'm running at a specific location, query Oak Ridge DAC and say what data sets are in the DAC within some radius of this location I'm interested. What data sets are on Dryad? What data sets are in other repositories? What data sets are in Neon? What data sets are on various NAS remote sensing products? And just to be able to make it easier to search for and ingest data from cloud resources. And then ultimately to make it easier to push back to those archives as well. Say, I've done all of my modeling within this framework. I want to publish in a journal that requires openness, and so we want to be able to just push of a button say, push this back to Dryad and get a DOI that you can then give to ecological applications or PLOS One or wherever you're publishing that says you need to provide a pointer to the work you've done. Okay, data ingest. Again, a key part. I conceptually divide data into 3 categories. Trait data, basically things broadly that can constrain individual parameters. Data that provides inputs to models, and data provides constraints on the outputs. On the trait data, we leverage internally a database called Betty. Put a lot of work on a lot of it. David's done since he first started as a postdoc in my lab years ago. It's building this database and supporting trait data in there. We've got a beta version of how to ingest try. We haven't put try in as a whole because it's something you need to get data requests from. But we're providing scripts that says if you get a data request from try, run this script and it will put it in your local copy of that database. On inputs, right now we can take any inputs that are basically registered with the database. So just say, I have a specific file format that my model's inputs comes in, and I'm just going to, those already exist, I'm just going to tell your database where they are, and then you can run your model through it. Beyond that, in terms of automating the ingest, we spend a lot of time on metadata. So these are the sorts of data sources that we're supporting right now. We've also spent some time on standardizing tools for converting in and out of that standard extraction data, and Ankur spent a good bit of time on a kind of a beta gap filling system. For vegetation, we have beginnings of a system that can ingest forest inventory data and land cover data. Right now, that unfortunately is only head specific, but Josh's work is going to generalize that. And then on constraints, things that kind of go in for data assimilation. Right now, we can, again, support things that have been registered with the system. So if you say, tell our database, here's some files that have Ameriflux data, they can handle those. And a lot of what Betsy's doing right now is beta testing a system that will ingest data just based on its MIME type. So it's a generalized system that can read any CSV data and align it with model output, or read any